Good morning, dear students. So, today we are coming to the last part of physical quantities and measurement. To talking about the theoretical explanation, it is done already. No theoretical explanation is left. So, today we'll do a little theoretical explanation, what we think you should know that. And after that, we'll discuss some questions. Okay, one revisions, and after that, I'll give some questions to you as a test and you will give it. Okay, and then this chapter will be completed. From next day we'll start a new chapter. The last thing I want to show you, I want to explain you that relation of temperature with density. So we have learned density. I just want to know how the density is changed with the temperature. Means how temperature and density is related with each other. Now we have learned one thing. What we have learned earlier, that as the temperature is increased, the volume of a body increases, and this is known as expansion of a substance. So we have learned it in class 6 that as we have increased the temperature of a body, then what will happen? We have learned earlier that in a body, whatever the substance we are talking about, it is made by molecules. As the temperature increases, the movement of the molecules are increased, so they will occupy more space, and that's why the volume is increased. Okay, now we know that density D equals to mass M by volume. Now you see, as D equals to M by V, so if you increase the temperature, the volume will increase. As the volume will increase, you see, volume is in denominator. So if volume is increased, then the density will be decreased. Simple thing. Volume is in denominator, so as you increase temperature, volume is increased. I have already written here. So as the volume is increased, you see the density will be decreased. So we can write down more temperature, more volume, and less density. So as the volume is increased, density decreases. Okay, so we can conclude that if you increase the volume, then the density decreases. So if the temperature increases, density decreases. That one I just want to show you. Simple thing, I'm just telling it step by step. As the temperature increases, the volume will increase. As the volume will increase, density will decrease. So here, if the temperature increases, density decreases. So it is the relation of temperature with density. Okay, so I have already written temperature increase, volume of the body increases, and that is known expansion of substance. As the body expand, you know, mass cannot be changed. Mass is a quantity which should always be constant. So volume expands. that means denominator increases, so density decreases. So we can say as the temperature increases, density of the substance decreases. Okay, this theory is same for all the body around us, except an exception is also there, and that is the exception of water. Exception for water. What exceptional things it shows? We have already seen that if I increase the temperature, the volume increases. Okay, but for water, there is a problem. We know if I am talking about the range of water, the water will be water from 0 degree centigrade to 100 degree centigrade. At 0 degree centigrade, you know, ice is converted into water. Okay, and 100 degree centigrade, water is converted into steam. And from 0 to 100, this range, it is in liquid state, that is water. Okay, that is water, what we are talking about. Now, if I increase the temperature from 0 to 1 to 2 to 3 to 4, so whether as per the another bodies, the volume should be increased. But for case of water, I have told an exception. What is the exception here? Just see. It is told from 0 degree centigrade to 4 degree centigrade, volume of water decreases instead of increasing. What is that? We have learned as the temperature increases, the volume will increase. But here, for the case of water, from 0 degree to 4 degree centigrade, the volume of the water decreases instead of increasing. And if you increase more, from 4 degree centigrade to up to 100 degree centigrade, volume of water, it will increase. Okay, I'm sorry. Okay, so 4 degree centigrade to 100 degree centigrade, there is no problem with that. But if I'm talking about 0 to 4, instead of increasing, it is decreasing. And it is told that at 4 degree centigrade, volume is minimum. At 4 degree centigrade, volume is minimum. Now, what does it justify? What does it justify? That we have to see. So I'm erasing this thing. Okay, that one is very common, that we have already learned earlier. Now from 0 degree centigrade to 4 degree centigrade, that is a tricky thing here is going on. At 4 degree centigrade, volume is minimum. We know density equals to mass by volume, right? So at 4 degree centigrade, volume is minimum. So volume is minimum means denominator is minimum. So in a fraction, if denominator is minimum, if I give an example, assume one is 2 by 5, another one is 2 by 3. Okay, which one is larger? So you will say, sir, 2 by 3 is larger than 2 by 5. Then I am asking why? Why it will be larger? You will say that, sir, here denominator is less and here denominator is more. So if denominator is more, the quantity will be decreased. If the denominator is less, the quantity will be increased. Here I have told at 4 degree centigrade, volume is minimum. That means here at 4 degrees centigrade, the denominator is minimum. That means the quantity, that means the density, what it will be. If denominator is minimum, that quantity will be maximum. So we can say that at 4 degrees centigrade, density of water is maximum. And one thing I am clearing you, that it is for water only. It is not for any another body. Keep that thing in mind. It is only for water. For water at 4 degrees centigrade, volume is minimum, and at 4 degrees centigrade, the density of water is maximum, and its value is 1 gram per centimeter cube or 1000 kg per meter cube. That is the density of water at 4 degrees centigrade, and it is maximum. So we can say that at 0 degrees centigrade to 4 degrees centigrade, what we have seen, the volume of water decreases. Volume of water decreases. So as the volume of water decreases, then the density will be increased. As the volume decreases, so the density will be decreased at 0 degrees centigrade to 4 degrees centigrade, and at 4 degrees centigrade the density will be maximum. At 4 degrees centigrade the density will be maximum, and from 4 degrees centigrade to 100 degrees centigrade, volume of water increases. Then the density will be decreased. This is the story. Okay, that is the exception with any another body with water. For any another body, if the temperature increases, the volume increases and the density decreases. That is one statement. But for the case of water, for 0 degree to 4 degrees centigrade, the volume is decreased instead of increasing. So here the density will be increased. And 4 degrees centigrade to 100 degrees centigrade, it is as usual. As the volume increases, the density decreases. This phenomena, this increase of volume or this decrease of volume from 0 degree to 4 degrees centigrade, that is known as anomalous expansion of water. It is anomalous expansion of water. It is a special name. It is an exception, so that's why a special name, anomalous expansion of water. Okay, so think about this. Otherwise, you means your senior, those who have given exam, they have done a mistake continuously. I have several times told it is only for water, but they forgot that thing and they write for any another body. If I am asking a question, what will happen with the density if the temperature increases? So they start writing 0 degree to 4 degree, volume decreases, density increases. I don't know. Whenever I am asking what will happen with the density with temperature, you have to write the general thing that as the temperature increases, the volume increases and the density decreases. Simple thing. But exceptional case is for water. For water, 0 degree to 4 degree, instead of increasing volume, the volume decreases, and 4 degree centigrade volume is minimum. That's why the density of water is maximum, and after that if you increase the temperature from 4 degree to 100, then again the volume increases and the density decreases. This is the exceptional expansion which is known as anomalous expansion of water. Okay, I think it is clear now. Now we are coming to the revision portion. What we have learned from this chapter. So one by one I am just mentioning the point. You can able to note it down in your copy. Several times you have asked that, sir, whatever you have written, you have to write down in your copy. I am telling it, yes, definitely. Whatever I have written in board, you have to write it down in your copy. It is your responsibility. Okay, as you are not having book, most of you have not having book, so that's why you have to write whatever I have written here. So revision, if I'm talking about the first thing we have learned here, that is volume. That is the definition of volume. Here we have learned that the space occupied by the object, that is known as volume. Okay, its SI unit we have learned, it is meter cube. CGS unit, it is centimeter cube. We have learned the relation 1 meter cube equals to 10 to the power 6 centimeter cube. Apart from that, to measure the volume of liquid, we have taken ml. We have learned 1 ml equals to 1 centimeter cube. Another unit system is taken, that is liter. 1 decimeter cube equals to 1 liter, and 1 liter equals to 10 to the power minus 3 meter cube. So that relation is been explained in the previous videos, so I'm not explaining this thing, which one is important. I'm just written that information of the previous portion. Okay, that we have learned volume. Number 2, how we can able to measure the volume. Measuring cylinder, and measuring beaker. These are the two instruments by which we can able to measure the volume. Now how we can able to measure the volume of regular shaped body? There I have given some equation, you have to go through it. That is, the volume of cube oil equals to length into breadth into height. Volume of sphere equals to 4/3 pi r cube. Volume of cylinder, it is pi r square h. Okay, volume of cone 1/3 pi r square h. So that one is given. You have to go through the previous video, you will get that idea. Next, volume of irregular shaped body. So here also we have seen that we have to put the body inside a measuring cylinder. Okay, and as you put the body inside the measuring cylinder, the level of the water is increased. And how much level of the water is increased? If it is V2, it is V1. So V equals to V2 minus V1. It will come in ml, and as it is a solid, that means V2 minus V1 centimeter cube, as 1 ml equals to 1 centimeter cube. So this is the process by which we can able to measure the volume of irregular shaped body. Okay, so that is the story of volume. Now we have come to what is area. Okay, how we can able to find the area? We all know that the space occupied by an object on a surface, that is known as area. Unit, okay, SI meter square, CGS centimeter square, and 1 meter square is equals to 10 to the power 4 centimeter square. Apart from that, many more units are there which is explained in the book as well as in my previous video also. So see that video again, write down that units, because from that unit in your exam the conversions may come. I'm not telling may, definitely it will come. So you have to do this. Area for regular shaped, I have already told some equation, it is written in the previous video, that is Area of a rectangle, it is length into breadth. Area of a square, that is length square. Area of a circle, that is pi r square. Area of a cylinder, it is 2 pi r h. Area of a sphere, that is 4 pi r square. And I think up to this only we have discussed. So these areas, these equations, these are very important. What is given there? So you have to go through that equation, write it in your copy, and you have to remember this. Now, shape or area of irregular shaped body. Simple thing, we have done it in a graph. It is done in the previous video, but I am telling one thing. From that portion no question will come, because I will not able to give any graph to you and to make the irregular shaped body. Okay, but from my side, one homework I have given today. Okay, that is, you can take the first project. Okay, that you can do. You can take a graph paper, whatever the graph paper you are having. It may be millimeter, it may be centimeter, it may be inch. So take a graph paper and measure area of two leaves, two different kind of leaves. Okay, so one leaves may be like this and another leaves may be like this. So two type of leaves you have to take. If you are having graph paper, I'm not telling that if you are not having graph paper, go to market, buy now. No, you should be stay at your home. Okay, and don't be panic, don't tell your parents also to go outside. If you are having graph paper, okay, I think maybe it is happened now, whatever the graph you have brought in previous classes, that can be here till now. So in that graph you have to take two leaves, you have to impression of that two leaves in two graphs, find the area by which process I have told. Okay, then if it is done, show me in the whenever the school gets open. Okay, several times I have told that no need to go outside for this. Okay, I'm coming to the next part. So this is all about volume and area. So next thing, which one is most important part of this chapter, that is density. Okay, so next we have learned about density. So density, just now I have told, it is mass per unit volume. Density D equals to m by V. Its CGS unit, which is mainly used, it is gram per centimeter cube, and SI unit, it is kg per meter cube, and relation 1 gram per centimeter cube equals to 1000 kg per meter cube, and the relation is also told to you. So I think no need to be panic. Okay, how the density will be changed with temperature, that we have discussed. Anomalous expansion of water, it is discussed. How you can able to find the density, you have to, if the mass is given, if you know the volume, you can able to find the density of the body. Okay, and if I'm talking about the density of a irregular shaped body, then I have told for irregular shaped body, for that case it should be D equals to m by V2 minus V1, where this is a measuring cylinder. You have put a body inside it. Initial volume is V1. After putting the body inside, the volume is V2. So this is the volume of the substance, that is V equals to V2 minus V1. And then you can able to find the density. Always remember the units, on which unit the density is asked, whether it is in gram per centimeter cube or kg per meter cube. Coming to the last portion, we have learned, that is speed. What is speed? We have learned speed equals to distance by time. Okay, so V equals to S by T. Generally, we have denoted. Apart from this, we have learned average speed. Okay, what is average speed? Average speed we have learned, it is sum of distances by sum of time. That is S1 plus S2 plus S3 plus dot 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 by T1 plus T2 plus T3. By the way, the displacement can be denoted as S1 or the distance can be denoted as D also. Okay, so I think in previous video I have used D, here I have used S. So don't need to be panic. It can be used by S, it can be shown by D also. No problem with that. Unit. CGS unit, if I'm talking CGS unit is centimeter per second, SI unit meter per second. 1 meter per second equals to 100 centimeter per second, and apart from that we use one unit, that is kilometer per hour. This is also one unit we have used several times because it is a larger unit. 1 kilometer per hour equals to 5 by 18 meter per second. Okay, so this is the overall thing we have learned in physical quantities and measurement. Okay, and today also we'll discuss some of the question, which one I think it seems to be very much important, and I have already given these questions to you. So let's coming to discussion of question answer. Okay students, we have to discuss some question answer, whatever we have already given to you. Assume the first question, it is given to you also. The density of brush is 8.4 gram per centimeter cube. What do you understand by the statement? It's a very common question. What do you understand by the statement? See, we know density D equals to M by V. So here 8.4 gram per centimeter cube means density, okay, density of a substance or density of brush is 8.4 gram per centimeter cube, means mass of 1 centimeter cube brush is 8.4 gram. Why I have written this statement? Because you see density equals to mass by volume. So as per here it is 8.4 gram by 1 centimeter cube. That means volume is 1 centimeter cube and its mass is 8.4 gram. So by that statement we can understand that density of a body is 8.4 gram per centimeter cube, means the mass of 1 centimeter cube brush is 8.4 gram. This is the answer. Okay. Number 2. If assume the density of two bodies is given to you. Assume density of aluminium is 2.7 gram per centimeter cube, and density, we have to mention here density, and density of assume brush is 8.4 gram per centimeter cube. So two densities are given to you. By that, if it is told, if I have taken of same mass, okay, both aluminium and brush, I have taken same mass, then what do you understand from their volume? Whose volume will more? If I have taken same mass of both substance. If I have taken same mass of both substances, then what do we understand about their volume or whose volume will be more? See, we know density equals to mass by volume, right? Here, if mass of two bodies are same, okay, then density will change with volume inversely. Now you may ask, sir, what is inverse? Inversely means, so mass, this is same. That means if I have taken volume equals to mass by density, see, from this equation we can write volume equals to mass by density. So here more density, less volume, and less density, more volume. Now you can say, sir, from where it has come? See, if I am going by this equation that volume is equals to mass by density, you see, if density is less, so denominator is less. I have told earlier, if denominator is less, volume will be more. So for case of aluminium, the volume will be more. But if I am coming to for brush, you see the density is more. So density is more means volume is less. So from this statement we can say that whose volume is more? Volume of aluminium is more. Volume of aluminium is more and volume of brush is less. Okay, this is the step by which you have to understand. Okay, I think by that questions you can able to understand what type of questions may come in exam. This type of questions may come in exam, so you have to be very careful about that. Now coming to some numerical, easy numerical. Assume the speed of two bodies have been told. Assume one body is A, another body is B. If I'm talking about speed, the speed of A body is 12 meter per second and speed of B body is 36 kilometer per hour. Now it is asked whose speed is more? Whose speed is more? Now you can say, okay, it is 12, it is 36. So 36 is greater. This speed is more. No. Here you see it is meter per second. It is kilometer per hour. That means we have to take this speed in same unit. Otherwise we cannot able to calculate whose speed is more. So convert it. We know 1 kilometer per hour equals to 5 by 18 meter per second. So 36 kilometer per hour equals to 5 by 18 into 36 meter per second, 10 meter per second. Here it is 12 meter per second, here it is 10 meter per second. So speed of A is more. Okay, so speed of A is more. So whenever we are talking about speed, we have to take it in same unit. Okay, this type of questions I will discuss one more. Assume if the speed of a body, assume a speed of a body, assume it is 3, it is 4. So speed equals to 72 kilometer per hour. Now the question is how much time it will take to cover 600 meter. Very interesting question. how much time it will take to cover 600 meter. Now you see, speed is given in kilometer per hour, and how much time will take to cover 600 meter, it is given in meter. So first we have to convert it meter per second. So 72 kilometer per hour is equals to 5 by 18 into 72. 18 fours are 20 meter per second. So this is the speed of the body, that is coming in meter per second. Why we have converting this? Because the total distance is given in meter. And now, which is asked how much time? We know speed is equals to distance by time. So time is equals to distance by speed. What is the distance? 600 time 20, 30 seconds. So this type of thing you have to remember, that you have to change the unit as per required. If you have not changed, you cannot able to answer the question. Assume this type of question may come like a body covers. I have discussed several questions. Maybe you are not able to understand it directly, so that time you pause the video, see it, okay, and then you will move forward. Next question, assume a body travels 15 kilometer in 20 minutes. Find speed in kilometer per hour and meter per second. Very interesting question. A body covers 15 kilometer in 20 minutes. Find the speed of the body in kilometer per hour and meter per second. So here distance is equals to 15 kilometer. Time is equals to 20 minutes. Now problem is that first time you have to cover, that is kilometer per hour. So 20 minutes, listen to me very carefully, 20 minutes equals to how much hour we have to find out, because it is asked kilometer per hour. If I want to find the speed, we know speed equals to distance by time. So distance is given to you, that is 15 kilometer, but time, you see, time is given in minute, but it is asked to find kilometer per hour. So 20 minutes equals to 20 by 60, 1 by 3 hour, okay, 1 by 3 hour. And now if I want to find the speed, we have to find it in kilometer per hour. So distance is 15, time is 1 by 3 hour. So this 3 will come up 45 kilometer per hour. That is the speed in kilometer per hour. Now it is asked, you have to convert it in meter per second. So we know we have to multiply with it by 5 by 18 into 45. That much meter per second. Okay, so if you calculate 3 6 3 15 3 5 3 2 25 by 2. Okay, so 25 by 2 meter per second, that means 12.5 meter per second. That will be your answer. Okay. So I am telling you one thing several times, that units are very important. Whenever you have to do anything, you should be very much careful about unit, on which unit it is asked. If you are not understand the units, then you cannot able to do it. Okay, Regarding the numericals of density, we have done several numericals. I think if you go through the previous videos, you will get it. If you are having any doubt regarding the numericals of density, you can ask me. Okay, so this chapter is completed. Thank you.